Okay, so continuing with line drawing and molecular representations, let's go yet to another example with more atoms. So now we have here, molecular formula is C4H10O. Now I am going to draw all possible combinations, ways that I can combine that. So in other words, I'm drawing constitutional isomers. That is molecules that share this formula, but the atoms are connected differently. And I'm using only line structures. Remember that I have 4 carbons, 10 hydrogens, 1 oxygen. So I'm going to put them several ways. So I can do 4 carbons on a line, 1, 2, 3, 4. And then I put my oxygen. And I need the hydrogen attached to oxygen. I need to show. Remember that key here. When we do line structures, we do not draw carbons and we do not draw hydrogens attached to carbon. But all the other hydrogens attach to other atoms such as oxygen, nitrogen, sulfur, those you need to draw. And this is what I did. 1, 2, 3, 4, the oxygen and the hydrogen. You can do the bookkeeping and convince yourself, but here you have 3 hydrogens. You have 2, 2, and 2. So if you count those, you should have all of your atoms complete, right? So now you have 5, 5 is 10. Okay, that's one of the possible ways I can draw that. I'm going to get another drawing, and let's do, we're going to have 4, and I'm going to now connect the oxygen over here. And now, again, this is another constitutional isomers. This is at the end. I need 3 hydrogens here. I need 3 here. There's 2 here. If I were to draw the condensed formula, remember. The carbon here has 1, 2, 3 bonds, so I need 1 here. So in here, I can add those up, goes to the same molecular formula, right? So these 2 also have something in common, which is your functional group. These 2 are alcohols. And they have that OH, and they can do hydrogen bonding as we showed before. Now let's do more combinations of that formula. So we can have, that's my oxygen in the middle. And now I have 2 carbons here, 2 carbons here. That's another functional group, and this is an ether. So anything that has an oxygen in 2 different R groups are, for example, methyl, ethyl chains, carbon chains. So that's an ether, and I have 4 carbons. But I can do also an unsymmetrical ether. I can have this. And I here have 1 carbon, and this is 1, 2, 3, so 4 total. Doing my counting the hydrogens that I need, here I would need 3 more, and 2, and this is 2 and 3, that's 10 hydrogens. And notice that here I don't have hydrogens attached to oxygen. So moving on to the other structure, here I need 3 more bonds, so 3 hydrogens, 3 more. Here I have 1, 2, 3 bonds, so I need only 1 hydrogen, and here I need 3. If you add those up, that will be 10. So that is another ether, is in this form. And do I have any other combination? Let me think about that. Yes, I do. I can have this, the 1, 2, 1, 1, 2, 3. So that will be different still. I will have 3 carbons here and 1 carbon here. So now in my counting hydrogens, I have 3 here, 2, and 2. That's all my count. All of those are constitutional isomers sharing that. So I'm going to give you physical properties, the boiling point of those, so that you see how the molecular structure impacts a property such as boiling point. So, for example, this is butanol, and for that, the boiling point is 117.7 Celsius. That is 2-butanol. That's one right here, 2-butanol. This is 1-butanol, or simply butanol. This one right here has a boiling point of 99 degrees Celsius, so those two are liquids. And let's see how the ether behave. So now for the ether, I have, this is diethyl ether. So the name, the diethyl ether. And the boiling point for that would be 39. Now hold on, oh no, this is 34. So boiling point of this guy is 34. So pretty low. Can evaporate super easy. Now here I have methyl isopropyl ether, and for that the boiling point is 30.7. So notice that here you have chances of forming hydrogen bonds, so harder to break intermolecular forces. So boiling point of this two is higher than the boiling point of that ether. Last ether here, I have the boiling point of 39 degree. So again, notice whenever I have alcohols, I can do hydrogen bonding on all of those. Hydrogen bond makes it harder to break intermolecular forces to go from the liquid phase to the gas. So you see higher temperatures. These do not have that. They only have dipoles in long non-dispersion forces. So here's how we can, with a molecular formula, there are different constitutional isomers, understand when I'm reading it, how many hydrogens are there in each carbon, and then how can we relate structure to a molecular property such as boiling point. Okay, that will be all for now.